Okay, so we learned that logic gates are basically in the physical computing. Logic gates, we are using that for implementing the electronics inside the computer. To implement the electronics inside computer, we are using logic gates. To implement the electronics inside computer, we are using logic gates. And so these logic gates, actually we learned about 3 logic gates. Can you remember the names of them?
AND gate, OR gate, NOR gate, NOT gate.
AND gate, OR gate, and NOT gate. So can I know the specialities of those gates? So what are the specialities? AND gate, what is the special feature?
We have to use both ports.
No. So it's not the exact answer. Can you find
Must
it?
be active.
Sorry?
All the inputs must be active.
Yes, all the input must be active to get the active output. If you need active output or if you need output as 1, you need to activate or you need to give all the inputs as 1. So that is the specialty of AND gate. Okay, what is the specialty of OR gate? OR gate. So what is
We can use one.
No, that's not the thing. So what is the specialty of OR gate then? AND gate, correct. If all the inputs are true, output is true. Or if all the inputs are 1, output is 1. OR gate. Yes.
We can get the connection if there is at least one there.
That is also correct. If we can get output 1, so if we can get output 1 if at least one input is 1. But that is not the specialty. That is also true. So what is the specialty? That's a special feature. We learned that. And about the NOT gate, okay, tell me about the NOT gate. Let's learn that later. What is NOT gate?
It inverts the connect which we give.
Yeah, it inverts the current input. So you have to always respond from these inputs and outputs, right? So even though it's like active, inactive, switches or water, whatever. So in your book, it's there as water and taps. So if you need water supply, you need to actually A valve and B valve both should be open. So actually this is example, right? This is only example. This is analogy for AND gate. This is not AND gate. This is analogy for AND gate. What is AND gate? So AND gate, actually we have to explain this using this truth table. So if all the inputs are 1, output is 1. That is AND gate, right? Analogy for AND gate, like if both valves are open, then water will come. If there are 3 valves, or if all 3 are open, water will come. If there are 4 valves, if all 4 are open, water will come. And we learn about the circuitry one also. Api circuit ගැන ඉගෙන ගත්තා අපි. දැන් water valve ඔක්කොම open කළා නම් වතුර එනවා. හරි, ඒක තමයි analogy එක. Analogy එක කියන්නේ ඒක තමයි මේ AND gate එකේ behavior explain කරන්න පුළුවන් ඒ විදිහට. හැබැයි AND gate එකේ කොහොමද වැඩ කරන්නේ කියලා AND gate එක මොකක්ද කියලා ඇහුවොත් දැන් මෙතනක් තියෙන AND gate එකේ behavior එක. If all these inputs are true, right here, if all these input or if all these switches are on, then bulb is on. That is analogy, right? This is the analogy. Analogy means how this works. It suggests the logic. එකේ තියෙන තර්කය මොකක්ද කියලා තමයි මේකෙන් කියන්නේ. හරි, ඔක්කොම switches වහලා නම් bulb එක පත් වෙන එක තමයි තර්කය. එකක් හරි අරලා නම් bulb එක පත් වෙන්නේ නැහැ. හැබැයි AND gate එක මොකක්ද කියලා අහුවොත් අපි කියන්න ඕන මේක. Right? AND gate එක මොකක්ද කියලා අහුවොත් we have to tell. So AND gate will output 1 if all inputs are 1. Okay, that is the logic of AND gate, right? So you can write that logic. That is the special thing, right? So if you miss that, please write down somewhere closer to AND gate. So put asterisk or triple asterisk, whatever number of asterisk can write down the logic of AND gate. If all inputs are 1, AND gate will output 1. And that is what AND gate is. That is how you explain. If all the inputs are 1, AND gate will output. That is how you explain. Right? But logic you can explain using various things. Switches ඔක්කොම වහලා නම් bulb එක පත් වෙනවා කියන්න පුළුවන් logic එකට. Tap ඔක්කොම ඇරලා නම් වතුර එනවා කියන්න පුළුවන්. Tap එකක් හරි වහලා නම් වතුර එන්නේ නැහැ කියන්නත් පුළුවන්. නැත්නම් switch එකක් හරි ඇරලා නම් bulb එක පත් වෙන්නේ නැහැ කියන්නත් පුළුවන්. විශේෂ ලක්ෂණය තමයි switch ඔක්කොම වහලා නම් bulb එක පත් වෙන්නේ. එතකොට ඕක AND එකක් විදිහට explain කරනවා නම් we have to tell if all the inputs are 1 and get will output. Oh, කියන්න පුතේ.
Sir, I joined now because of an Android problem. Can you tell what were you doing?
We were discussing about the last day lesson, right? We were just revising that. Okay, we discussed about the speciality of AND gate, and this is it. If all inputs are 1, AND gate will output 1. Okay, then let's go and see the analogy of OR gate. OR gate එකේ analogy එක බලමු. logic එක මොකක්ද කියලා. OR gate එකේ logic එක තියෙන්නේ if B valve is open, water will come. If A valve is open, water will come. Water will not come only if both valves are closed. නේද? මේ දෙකම වහලා නම් වතුර එන්නේ නැහැ. මේ පැත්තෙන් එන්නත් බෑ, මේ පැත්තෙන් එන්නත් බෑ. මේ දෙකම වහලා නම් වතුර එන්නේ නැහැ. ඒක තමයි analogy එක. ඒක නැත්නම් logic එක. හරි, logic එක ඒක වුණාට කොහොමද අපි OR gate එක විස්තර කරන්නේ? How we explain OR gate? If both valves close, water will not come. That is not OR gate. If both valves close, water will not come. That is not OR gate. Here, see the other one. Make it api kiwe. Okay, see these circuit diagrams. Right? If both switches are open, bulb will not work. If both switches are closed, bulb will work. If one switch is closed, then also bulb will work. If the other one is closed, then also bulb will work. But if both are open, bulb will not work. So what is the explanation for OR gate then? Can you tell it now at least? Yes. Thank you, Nilanjana.
It will output 0 if all the inputs are 0.
Correct. එහෙම තමයි එක කියන්නේ. Right? අර AND එක කිව්වා වගේම තමයි කියන්නේ. It will output 1 if all the inputs are 1 කිව්වා වගේම තමයි. O එකෙත් කියන්න වෙන්නේ 1 0 වලින් කියන්න ඕනේ. It will output 0 if all the inputs are 0. මේ තියෙන එක ලියලා තියෙනවා. It will output 0 if all the inputs are 0. That we have written. Okay. Then the NOT gate simply it will invert. If 1 comes, it will invert to 0. 0 comes, it will invert to 1. Now, can you understand OR gate, AND gate, and NOT gate?
Yes, sir.
Okay. Is there any?
Sir. Excuse me, sir. I couldn't come to the class before the last week. The week before the last week. So, can you please put the recording?
I think recording is already there in the jits.lg site.
Okay, sir.
Not in Edmodo, right? Because you are putting this, you are putting this.
Sorry, what, sir? What's the website?
Jits.lk.
GICTS?
Yes, .lk.
Okay, sir. Thank you, sir.
You have to have a login to access that. Right?
Okay,
Right.
sir.
Okay. Then we know about the tree implementation, and then we learn how to combinationally implement that. That means how to combine 2, 3 gates and create 1 gate. That we learn. In your book also, it is there after learning the basic gates. Then how can we combine the other gates and create combinational logic gates? Actually, we should know this 1 0 things. We should know this 1 0 thing. Why 1 0 things come? Because so here building blocks or the basic elements of the CPU, ALU or computer is basically logic gates that you should know. How we are going to create electronics that is using logic gates. And basically computers are using which kind of signal? Is it digital signals or analog signals?
Digital signals.
Yes, computers are using digital signals. Why digital? Why they can't use analog? Why computers cannot use analog?
Analog are slow.
Not actually. We are using analog now. Our voice is analog.
Computer cannot understand analog
Yes, why computers cannot understand analog?
because they are machines.
Yes, because they are machines. So can't they actually understand analog?
If we convert analog to digital, they could understand.
Yes. Why? What's the reason? Because digital has only few status. Right?
Using analog language.
Because digital has only few status. Right? So basically, presence you can say in digital, presence is 1, absence is low. High voltage is 1, low voltage is low. That is simple to understand because voltage computers can understand, or bulbs can understand that. If a voltage come to a bulb, it will lighten up. And no voltage, it will turn off. So that is simple enough, right? If voltage is there, it will turn on. If voltage is not there, it will turn on. Right? So that is the reason why we have to present everything in binaries, ones and zeros, or digital format. Digital format has only few status. It's easy to give. But if there are more status, it is very complex. Status dana meter.
Using other languages like hexadecimal, octal.
That is also having few status. No? Only defined status that you can explain using binary. Even status gana limited na ප්‍රශ්නයක් නෑ digitize කරගන්න පුළුවන්. හැබැයි stages status ගාන වැඩි නම් ඒක represent කරන්න අමාරුයි. හේතුව දැන් අර on off අතර තව ගොඩාක් ඒවා තියෙනවනේ. So it's very complex to computer or electronic device. But if it is only on and off, it's very easy to distinguish. Right? Because only two status. Any place you can represent two status easily. But multiple status is very difficult to explain. So because of this easiness, it's adapting to these two status logic or digital logic. That is the reason. Okay. Then these logic gates are actually processing this digital information. Right? Ones and zeros. It take ones and zeros and produce the output as ones and zeros. So that is why we use ones and zeros to explain everything. Okay, let's go and write down small note over there. Right? Actually, you can, I'll write the note closer to the singular medium note. Those who need actually can take a screenshot of singular medium note. So then it will be like easier to you to understand in case if it is difficult. But if it is not difficult, like, so then English note is also enough. Okay, please write down. We use two types of signals. Analog signals can take any value between a given or acceptable range. Example, we can hear between 20 Hertz to 20,000 Hertz.
20,000, sir.
Yes, 20 Hertz to 20,000 Hertz. That is a range. Between that, we can hear any sound. Digital signals will take only a few specific values in between a given range. Example, on, off. Electronic components are not intelligent enough to understand different levels of signals, as it will become more complex to design such hardware. Even after designing such, it will be slow due to complexity. Therefore,
Excuse me, sir.
yes,
Is that artificial intelligence?
no, artificial intelligence or whatever intelligent, you don't, the bulb is not intelligent, no? Right?
Yes, sir.
Nothing called intelligent is there in electronic devices. Transistors are not intelligent. LED bulbs are not intelligent. Wires are not intelligent. Therefore, it is preferred to explain things using less amount of levels or signals, as it reduces the complexity. It mostly uses two status logic. Like on is 1, on equal to 1, off equal to 0. Similar to that, you can say open is 1, closed is 0. Closed switch or working switch is 1, open switch or inactive switch is 0. Light is 1, dark is 0. Some examples, right? Active is 1, inactive is 0. Present is 1, absent is 0. High is 1, low is 0. Or you can say 5 voltage is 1 specifically, 0 voltage is 0. We have to convert every single analog data and signals to digital to represent in computers. It includes converting numbers, letters, graphics, audio, and video. The two-status logic language that computers can understand is called machine language. It's called machine language. The two-status logic language that computers can understand is called machine language.
So that is binary. So that is binary.
Yes, it is created using binaries, right? That means 1 and 0. It is not 1 0, but it is created using. It is a language created by using 1s and 0. It is not just 1 and 0, right? It is like 1 and 0, combinations of 1s and 0, maybe few 1s, few 0s, 1 0, 1 0s. Likewise, it's combinations of 1 0 patterns. Logic gates that we learned are working with these binary data and signals and producing binary outputs. Those are the basic elements for CPU, ALU, CU, memory, and all other components in the computer system. So this is very important note. So it explains the binary and it explains the machine language. It explains why you need logic gates and all, and also the two-status logic. Here, please edit as single, right? SINGL, single. Okay, let's go back and let's see what's in the book. Right, that is it. And then the summary. Actually, we have to discuss the workbook, but my plan is to start the new chapter today. That is work with internet, because it is interesting one, and we can focus on the workbook next day. And I said that you have to download a special software according to the workbook here. This is the workbook version.
So Logic, right?
Yeah, multimedia logic. This is it, Logic, and we will be doing this using Logic, multimedia logic next day. Right? Please download it and install it.
Sir, what's the name? Can you please say again?
Multimedia logic. It's in the workbook. Multimedia logic.
Thank you, sir.
Okay.
So, or you can use that online version called DLetch. It's another software, but it's also good.
What is the name of software?
DLetch.
DLetch.
Yeah.
Yeah, there are many software. Like I said, that logic.ly is also another one. Likewise, yes, you can use many software, but since this is explained using Logic, that's why I'm just doing, because it's there in the book, right? Even logic.ly is easier than this, right? Okay, I'll do that next day. Let's move to the new topic, which is internet and maybe using internet. Okay, let's write down over there. Heading is internet. Actually, this heading you have learned in your grade 6 and 7 both. Therefore, you should have some idea about that. So first of all, can you explain what is internet?
The largest network of all the networks.
Yes, it's the largest network of all the networks. What else? Who owns that?
The whole world.
All world, the general public. And is it spreaded in a certain region or certain country or entire world?
Entire world.
It's covering the entire world. Okay, using these points, you can explain that is internet is a service or is it infrastructure?
Infrastructure.
Infrastructure. It's infrastructure. There are services running on top of that infrastructure. Right. Okay. So then let's write down that internet.
So what is the topic of the lesson? Oh, okay.
Right. Internet is the world's largest public wide area network, which is also known as a network of networks. It connects individual computers, computing equipments, and networks and computer networks together.
So I guess that should be the not networks, right? That third letter of the second sentence, the third word of the second.
It connects individual computers, computing equipments, and networks together. Yes, it's a network of networks. And networks together providing infrastructure to a wide variety of services. To a wide variety of services. It is owned by the entire world.
So providing or providing?
Providing infrastructure to wide variety of services. It is owned by the entire world or general public. So those are the things that we should know about that. Okay, so what are the services of the internet? So what are the services of the internet? One thing you can say is
Video conferencing.
Yes, video conferencing is another one. Good. www is one service. What is
World
www?
Wide
What is
Web.
www?
World Wide Web.
World Wide Web, right? Or the websites. That is one services. And anything else? As you said, the video conference. You can say generally teleconferencing. Teleconferencing. So examples: Zoom, MS Teams, Skype. Those are
Google Meet, go to meetings.
Google Meet.
Blue Jeans.
Yeah. So what are the other services? Any other services?
Videos.
Videos, meaning
Search engine.
search engine is also a website, right? That is also
Email.
Yeah, email. Email. or electronic mail. Anything else?
Social media.
Social media, yes. Social media. You can say Facebook, YouTube, Twitter.
What?
Vibe.
No,
Emo.
no. Facebook, YouTube, Twitter,
Instagram.
Instagram.
WhatsApp.
Those are some other services. WhatsApp, Viber, Imo, those are belongs to which category? Those are called instant messages. So that is like you can say WhatsApp, Viber, Imo, Line, instant, even YouTube, so even Skype and Telegram. So those are actually messaging systems. It's a messenger. Anything else? Okay, we wrote like 1, 2, 3, 4, 5 services. Only 5 services. Only 5
Telenet.
services. What do you mean by Telenet?
Movies.
Movies, actually movies, these are actually, movies are coming like either websites or it can come as a file. Basically, you can say file transfer. Then software, movies, everything comes there, right? Software, movies, information, documents, download, everything comes under file transfer. Anything else? Only that. World Wide Web, teleconferencing, email, social media, instant.
Remote access.
Remote access, very good. Remote access. That means being in one location, you can access another location. Right? So maybe remote surgeries.
Electronic
remote
fax.
camera,
Any desk.
any desk like services. Remote desktops. You can say remote desktop. So it covers like any desk, team view, right? Remote desktop. So and there are some services called news groups. News groups. And there are a category of services called VPN. Virtual private.
Private networks.
Yes, you can create your own private networks using this public infrastructure. ඔයාලගේම පුද්ගලික එකක් හදා ගන්නත් පුළුවන් මේ public එක පාවිච්චි කරලා. That is called virtual private network. Okay, if you disconnect, please reconnect using the same link, right? So these are the services that we are going to talk under internet, and we will look into some services today. So what are these services and how these services can be accessed? There are more services, right? But as I have mentioned only the major services that general public are using, but indexing services. So likewise, monitoring services. There are a lot of other services which is related to companies, organizations, institutions, security agents, militaries, governments, but I have not mentioned that. General services that we are using. These are there.
Sir, can you scroll up a bit up?